Today we'll be working on 6 weeks review. The table below shows the distance that different pilots flew last year. Which list shows the pilots' names in order from greatest to least miles they flew? Question, which list shows the pilots' names from greatest to least miles they flew? So we're looking for a list of names that are from greatest to least. So we look at our miles over here. Remember, when we're comparing numbers, we start with the greatest value and we work our way backwards. So we look at the 10 millions place. So they're all the same, they're all 3. In the millions place, we have 2 million. They're all the same, so we move on to the next one. So in the 100,000s place, they're all 200,000, so we can move on to the next one. Now in the 10,000s place, the numbers are not all the same. Remember, we're looking for the greatest number first. So if we compare 0, 1, 1, and 0, which of these is the greatest number? So we know that 1 is our greatest number. So one of these two would be first, either Walker or Rios would go first. So since they both have a 1 in the 10,000s place, then we can move back to the thousands place. So now we're at the thousands place, we have to find the greatest one. So we have 4,000 or 3,000. We know that 4,000 is greater than 3,000. So that means Rios would go first. And then this is 3,000. Walker would go next. We're not looking at Gomez or Owens because we're only looking at the ones that had a 1 in the 10,000s place. Gomez and Owens have a 0 in the 10,000s place. So Rios has 4,000. Walker has 3,000. We know 4,000 is greater than 3,000. So now we can go back and look at the ones that had a 0 in the 10,000s place. So Gomez has a 9 in the 10,000s place, and Owens has a 6 in the 10,000s place. We know that 9,000 is greater than 6,000. So Gomez would go third, and Owens would go last. This is the smallest one. All right, so now we can write our list. First was Rios. Second was Walker. Third was Gomez. And last was Owens. So we look for a list that matches ours, and it's right here. Rios, Walker, Gomez, and Owens. Our answer is D. Number 2 says which number is greater than 17 and 46 hundredths and less than 17 and 59 hundredths? Use the number line to solve. So we're looking for one of these numbers that is greater than 17 and 46 hundredths, but it's less than 17 and 59 hundredths. So first we're going to plot 17 and 46 hundredths on our number line. I know that here in the middle, in between 17 and 40 hundredths and 17 and 50 hundredths, is going to be 17 and 45 hundredths. And I know 17 and 46 hundredths, it's right next to 17 and 45 hundredths. So I will put 17, 46 hundredths on our number line, almost in the middle. Now 17 and 59 hundredths is here, 17 and 60 hundredths, and I know 17 and 59 hundredths is going to be close to 17 and 60 hundredths. So I'll put 17 and 59 hundredths, close to 17 and 60 hundredths. So now if we plot these numbers here, we should find a number that's in between these two. It's going to be greater than 17 and 46 hundredths, but it's going to be less than 17 and 59 hundredths. So we're looking at a number that goes somewhere in the middle. So first we try 17 and 44 hundredths. I know that 17 and 44 hundredths is less than 17 and 46 hundredths. So I'm going to plot it somewhere here, 17, 44 hundredths. So this can't be our answer because 17 and 44 hundredths is not in between those two numbers. So we can get rid of F. So 17 and 62 hundredths is next. So I know 17 and 62 hundredths is greater than 17 and 60 hundredths. So it would be somewhere over here. So 17 and 62 hundredths is not in between these two. If 17 and 62 hundredths is greater than 17 and 49 hundredths, but it's not less than 17 and 59 hundredths. So G cannot be the answer. So we're down to two. So 17 and 53 hundredths. So this is 17 and 50 hundredths. So 51, 52, 53, somewhere about here. It's 17 and 53 hundredths. So this number is between those two. It's greater than 17 and 46 hundredths, but it's less than 17 and 59 hundredths. So 17 and 50 hundredths should be our answer. If we look at our last one, 17 and 60 hundredths, it's already plotted for us and it's greater than 17 and 59 hundredths. So J cannot be our answer either. So our answer is H. Number 3. Brantley wrote the number below, 243,551. Which statement about the circled digit in Bentley's number is true? Its value is 10 times greater than the value of the underlying digit. B. Its value is 1/50th the value of the underlying digit. C. The value is 50 times the value of our underlying digit. Or D. The value is 1/10 the value of the underlying digit. All right, so whenever we're looking to see if is how much we're comparing these two, what is the value between these two, it says which statement about the circled digit in Bentley's number is true. So we want to know about this digit right here. So we're going to be comparing it with the underlying digit. So remember, if the number that we're comparing these two numbers, if the number we're comparing is behind the other number, then it's going to be 1/10 because we're going backwards. So it's going to be 1/10. If it's behind the number that you're comparing it to, then it's going to be 1/10. Now, if the number is in front of the number you're comparing it to, then it's going to be 10 times. So if we look at the circle digit, is this number in front of that number or is it behind that number? So we know it's behind this number. So this circled 5, the 5 in the tenths place, is 1/10 the 5 in the hundredths place. Right, so we have a base 10 system. So I know right away I can get rid of this 50 because our numbers go by tens, and I can get rid of this one. So now I'm either going to have A or D as my answer. Remember, if it's behind it, it's going to be 1/10. So this circled number is behind the underlying digit. So it is going to be 1/10 that number. So if we look at A, it says the value is 10 times greater than the value of the underlying digit. No, it's not 10 times greater. The answer is D. It's 1/10 the value of that digit. Number 4. The counter shows the distance in meters of the route for a bicycle race. What is the value of the digit 3 in this number? So we're looking at the digit 3. So we see our decimal here. So when we write it as a value, what is the value of the digit 3 in this number? So we have to keep our digit there. The 3 has to stay behind that digit, and we can put a 0 there. Right, so it's 3 tens. Our answer should be F, 3 tens. It's not in the hundredths place, so it's not 300th. And it's not in the ones place, so it's not 3 and 10 hundredths. So our answer is F. Number 5. The model below is shaded to represent a number greater than 1. What fraction and decimals are represented by this model? So we look at our hundredths grid. These are hundredths grid. And I know 2 of them are completely shaded in. And on this one, we have 84 shaded in. So these 2 are whole numbers because they're completely shaded in. So I have 2 and these are 8400. We have 2 holes and 8400. I can also write that as 2 and 8400 because this is a hundredth grid, it's not a tenth grid. So we have hundredth. So I can either write it 2 and 8400 as a decimal or as a fraction 2 and 8400. So if I look at our answers, I know these are hundredths grid. So right away I can get rid of anything that says tens because these are hundredths grid. So if we look at our remaining answers, 2 and 8400 and 2 and 8400. Our answer is C. If you remember that these are hundredths grid, we could have right away gotten rid of anything that has a tenth at the bottom because these are not tenths, these are hundredths. Number 6. The shaded model below represents 4 decimal numbers. Which list shows these decimal numbers in order from greatest to least? So these are our decimal numbers. So this is 10, 20, 30, 40, 800. So that one's 4800. This is 10, 20, 30, 40, 50, 800. And I'm putting my decimal there. And this is 10, 20, 30, 40, 300. This is 10, 20, 30, 40, 50, 100. So we have 4800s, 5800s, 4300s, and 5100s. So we're going to order them from greatest to least. So our greatest number here is 5800, and then it would be 5100, then it'd be 4800, and last it would be 4300. So we find one that matches ours, 5800s, 5100s, 4300s, and 4800s. No, 5800s, 5100s, 48. It should be F. Number 7. The number line shows point F. Which number does point F represent on the number line? So which number point does point F represent on the number line? So we're looking, what does point F represent? So let's look at between 2 whole numbers. So between 12 and 13, how many spaces do we have? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they're going by tens. So if I go, F is after 13, so I'm just going to count by 10. So this would be 13 and 1/10. So F would be 13 and 2/10. So that would be 13 and 3/10, 13 and 4/10, 13 and 5/10, and so on. So if we look, this represents 13 and 2/10. Our answer is B, because we're counting by 1/10 every time. So 13 and 1/10, 13 and 2/10, 13 and 3/10, 13 and 4/10, 13 and 5/10, and if we go on until we get to 14. So our answer would be B, 13 and 2/10. Number 8. Which expression's sum is equal to 5/3? So the sum equal to 5/3. That means we have to add fractions that equal to 5/3. So if I add 1/3 plus 1/5 plus 1/3, I have two different denominators. So I can't add fractions with different denominators. I'm going to cross that one out. So here we have 1/5 plus 1/5 plus 1/5. I know my denominator has to be a 3. So I know this denominator is a 5. This is going to be 3/5. It does not, is not the same as 5/3. So here we go again. The denominators are not the same. So that one cannot be it. This is the denominator of 3. This is the denominator of 1. We can't add those two. So we move on to J. So I have 1/3 plus 1/3 plus 1/3. That's 3/3 plus 2/3. That equals 5/3. 1 plus 1 plus 1 is 3 plus 2 more is 5. And we keep the same denominator. That is 5/3. So our answer would be J. Number 9. The two models are shaded to represent the same fraction 6/8. Which equation shows the two models represent the same fraction? So it says which equation shows the two models represent the same fraction? So if we look at this model first, we know we have 3 darker shaded ones and 3 light shaded ones. So on this one, we can say 3/8 plus 3/8, and that equals 6/8. So now if I go to this model, I have 2 darker shaded ones, so I go 2/8 plus, and now we have 4 shaded ones, 4 light shaded ones, these 2 and these 2 over here. So I can say plus 4/8. And that gives me 6/8, and this gives me 6/8 too. Right, so now if I go down here, right away I can get rid of B and D because our denominators are wrong. These should be 8, and denominators over here, we have 3, 3, 2, and 4. Same thing here. The denominators are wrong. They should all be 8, like these two. So B and D are wrong. So let's look at A. 3/8 plus 3/8 equals 2/8 plus 6/8. All right, we have 3/8 plus 3/8 over here, we have which is 6/8, and we have 2/8 plus 4/8, which that equals 6/8. So these two are equal. So I can say these are equal to that. A is our answer. If we look at this one, we have 3/8 plus 3/8. We have 3/8 plus 3/8 there. Over here, we have 2/8 plus 5/8. We should have 4/8 because 2 plus 5 is 7. So this would be 7/8. So these two would not be equal. So we can get rid of C. Our answer is going to be A. Number 10. Jessica worked 3 1/5 hours at a pet shelter on Friday morning. Friday afternoon, she worked 2 2/5 hours. Ignacio worked a total of 3 4/5 hours on Friday. What was the difference between the number of hours Jessica and Ignacio worked at a shelter on Friday? So we say, what is the difference between the number of hours Jessica and Ignacio worked at the shelter on Friday? So we know that when we're trying to find the difference, we're going to subtract. So what are we going to subtract? Jessica and Ignacio's hours. So I know Jessica worked 3 1/5 hours, and Ignacio worked 3 4/5 hours. So if we want to work Oh, wait a minute. So here we go. She also worked. So Jessica worked 3 and 1/5 hours at the pet shelter on Friday morning. Friday afternoon, she worked 2 and 2/5 hours. Ignacio worked a total of 3 and 45 hours. So here we have to find Jessica's total hours. So I know Jessica worked 3 and 1/5 hours in the morning, and then she worked 2 and 2/5 hours in the afternoon. So these are Jessica's hours. So we can add what's 1/5 plus 2/5. It's 3, and our denominator stays the same, fifths. And then we add our whole number. What's 3 plus 2? That's 5. So Jessica worked a total of 5 hours, 5 and 35 hundredths hours. 35 3/5 hours. Sorry about that. All right, so we have Jessica's total. Ignacio's total is 3 and 4/5 4/5 hours. All right, so we're gonna have to subtract because we're trying to find the difference. So Jessica had the greatest amount of hours, so we'll put her first, and then Ignacio worked 3 and 4/5 hours. All right, so we're subtracting. So now we go here. Start with our fractions. So we're subtracting 3 minus 4. Can I subtract 3? And we can subtract 4 from 3. If I only have 3, I can't subtract 4. That means we have to regroup. All right, when I regroup, I'm going to take a 1 from there. This becomes a 4. And remember, 1 whole equals, right, our denominator is 5. That means I have 5 out of 5 pieces. So when I take this whole from here, I'm actually bringing 5/5 over here. So that means I'm going to add 5 more here. I go plus 5. 3 plus 5 is 8. So now here, I don't have 3/5 anymore. I have 8/5. So now I can subtract. What's 8 minus 4? That's 4. And I still keep my same denominator, 4/5. Now what's 4 minus 3? That's 1. That's 1 and 4/5. Our answer is J. Remember, whenever you regroup and you bring it up to a fraction, you have to remember that 1 whole that you're regrouping is your denominator, and that's the same number of parts in your numerator. So if denominator is 5, then it's going to be 5/5. If your denominator was 3, then it would be 3/3. That would make up 1 whole. And then you bring your 5/5 and you add them to your 3/5. That would give you 8/5. And then you can subtract from those 8/5. Number 11. Mrs. Hampton bought a chocolate chip cookie pizza and sugar cookie pizza for a school party. The shaded part of each pizza represents the fractions of each cookie pizza that was eaten. Which expression can be used to find the difference between the fraction of chocolate chip cookie pizza that was eaten and the fraction of the sugar cookie pizza that was eaten? So we're trying to find the difference between the fraction of the chocolate chip cookie that was eaten and the fraction of the sugar cookie that was eaten. Remember, when we're finding the difference, we know we're going to subtract. So we look at the chocolate chip cookie. So we have to figure out how many pieces they had all together. So they had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I know my denominator is going to be a 12. And the 8, 1, 2, 3, 4, 5. They ate 5/12 of the chocolate chip cookie. Now we look at the sugar cookie. Again, find how many pieces there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So those 12 pieces becomes my denominator. And I know they ate 10 because there was 2 left. So 12 minus 2 equals 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 twelfths of the sugar cookie was eaten. So if we're trying to find the difference, I know I'm going to put 10 12 minus 5 12. So if we look over here, right away I can get rid of B, C, and D because they have the wrong denominator. So my answer would be A, 10 twelfths minus 5 twelfths equals 5 twelfths. Number 12. Each week, Mr. Nolan drives 2,289 miles to El Paso making deliveries. Which is the best estimate of the number of miles he will drive to El Paso in 8 weeks? So it says, which is the best estimate of the number of miles he will drive to El Paso in 8 weeks? So we know that he drives 2,289 miles to El Paso making deliveries, which is the best estimate of the number of miles he will do in 8 weeks. So each week he drives this many miles. We want an estimate. So anytime we're going to estimate, we're going to round our given number. So we have 2,289, and I'm going to round it to the nearest thousand. So this 2 is going to tell us what to do with the 2 in the thousands place. So the 2 is less than 5, so I know this one's going to stay the same. So this 2 stays the same. Now anything behind it, any numbers behind it will become zeros. So this rounds to 2,000. So this is about how many miles he drives every week. Now we want to know for 8 weeks. So we have 2,000 every week. So we multiply times 8. That gives us about how many miles he drives in 8 weeks. So I can go 2 times 8 is 16. And then just bring back this trailing zeros. So I have 3 zeros. So my answer is 16,000. So he drives about 16,000 miles in 8 weeks. So our answer is F. Number 13. During a book fair, a librarian sold 118 bookmarks and 97 erasers. The bookmarks cost $3 each. The erasers cost $2 each. Which set of equations can be used to find T, the total amount of money that was made from the sale of these two items? So we're looking for which set of equations can be used to find T, the total amount of money that was made from the sale of these two items. All right, so we know they sold 118 bookmarks and 97 erasers. The bookmarks cost $3 each, and the erasers cost $2 each. So we have 118 bookmarks, and we can multiply that times the cost of each bookmark, so times 3. So we have 8 times 3, 8, 16, 24. 4 regrouped to 2. So 3 times 1 is 3, plus 2 more is 5. Then 3 times 1 is 3. So now we have to look at our erasers. We had 97 erasers. And we multiply times the cost of each. Each eraser will cost $2 each. So we multiply 2 times 7 is 14. 4, we group the 1. So now we have 2 times 9 is 18, plus 1 more is 19. Right, so now we found the cost of the book, how much they made on the bookmarks and how much they made on the erasers. All we need to do is add these two, 354 plus 194, and that should equal T, the total cost of the two items that they sold. So now if we look for our equations, I know I have to multiply 118 times 3. So let's look at 8. This is 118 times 2. It can't be 2 because 2 was the cost of the erasers, not the bookmarks. So I can get rid of A. So let's look at B. 118 times 3 is 394. Yes. Then 97 times 2. 97 times 2 equals 99. Here they didn't multiply, they added 2. So it can't be B. So we look at this one, 118 plus 3. Here they added instead of multiply. So it can't be C. So our answer has to be D. 118 times 3 is 354. 97 times 2 is 194. And then we add 354 plus 194 equals D, the total amount. So our answer is D.